Okay, now recording. See if I can share the screen here. All right, so we're into Trig. Still kind of keeping the schedule. We start at 6.1. We'll do 6.1 and some of 6.2 today. Okay, tomorrow 6.3 and a quiz. The quiz will not be on trig, it'll be on exponential and log equations. Okay, so just to let you know, the quiz tomorrow. The basic idea is how do you cancel an exponential with an e? You do a natural log. And how do you get rid of a natural log? You put an e. Okay, that kind of thing. So you have equations that have natural logs and you have exponentials like e to something. And to get rid of it, you do the other function. So to get rid of an e, you do an ln. To get rid of an ln, you do an e. Okay, so that'll be tomorrow. Right. And a reminder, I'm moving the date of the exam back to Thursday, the 18th. Okay, and that'll cover chapters 5 and 6. Again, I'm already done with chapter 5, and we're starting 6 now. Okay, so here's where we're at. So coverage for that test will be chapter 5, which I'm already done, and 6.1 to 6.4. Okay, there's still a lot more trig. This is all trig. This is all trig. This is all, we got quite a bit of trig still to go in this class. Okay, so I did a little bit of 7.1. I'll do much more right now. Again, quite a bit of this is calculator dependent, so you want to have your calculator handy for the problems that we do here in 6.1. I may have said 7.1. Sorry, 6.1. All right, and recall we were giving you the Sohcahtoa, right? So you want to be comfortable with Sohcahtoa. So just a quick reminder of where we were. Nice little memory trick. Sohcahtoa. So we have a right triangle. I'll call this theta. Okay, this is the hypotenuse. This is the adjacent side. This is the opposite side. Now, I may draw a lot of triangles like this, but it does not have to be situated like that. Okay, I mean, obviously, if I turn the paper, it doesn't change anything. So your triangle might look like that, or like that, or like that, or like whatever, right? It doesn't make any difference. Okay, whatever the picture looks like, from your theta, there's an opposite side, hypotenuse, and adjacent. And so what is Sohcahtoa? Sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. And tangent of theta is opposite over adjacent. Okay, so we had these. Okay, so I did some problems last time and we'll do several more, hopefully. Okay, so I was going to do number 11 for you. So 11, AB is 25, AC is 24. Compute each of these things that they have you here. Okay, so 11. You're given triangle ABC. Just do a quick sketch here. All right, and then they tell me that distance from A to B is 25 and from A to C is 24. AB is 25, AC is 24. Okay, so they don't give me BC, but I can figure it out. So let me call it X. So use your Pythagorean theorem. X squared plus 24 squared equals 25 squared. Okay, punch these in your calculator if you wish. X squared plus 24 squared is 576. 25 squared is 625. Subtract 576 on both sides. X squared equals 49. Square root. Normally you need plus or minus, but we're only doing positive quantities. So X is 7. Okay, so we figured out that this is 7. All right. All right, then it's asked you for everything about cosine, sine, and tangent of A and B. All right. So cosine A, sine A, tangent A. And then they also ask you for the same thing involving B. Cosine B, sine B, tangent B. Okay, cosine, ka adjacent over hypotenuse. So angle A, the adjacent is 24, the hypotenuse is 25, so 24 over 25. Okay. Sine of angle A, opposite 7 over hypotenuse 25. Okay, and by the way, you'll notice that we have no way of doing this problem unless we figure out this side. Okay, so some of the problems are only going to give you 2 pieces of information, and you have to figure out the third piece of information. Okay, tangent of A, TOA, opposite over adjacent. So opposite over adjacent, 7 over 24. Okay. All right, then they ask you the same thing for B, cosine, sine, and tangent. Okay, so with respect to angle B, cosine, ka, adjacent over hypotenuse. So adjacent, 7 over hypotenuse 25. So 7 over 25. Sine of B, opposite over hypotenuse, 24 over 25. And tangent, TOA, opposite over adjacent. So 24 over 7. Okay, as I mentioned before, this will always be true for the 2 complementary angles A and B. The cosine of A is the same as the sine of B, and likewise the sine of A is the cosine of B. And that actually makes sense because if you want the cosine of A, it's adjacent over hypotenuse, 24 over 25. Sine of B is opposite, that's still 24, and the hypotenuse is still 25. So that obviously makes perfectly good sense. Okay, and then the last thing they asked for is tangent A times tangent B. Tangent A times tangent B. Well, it's 7 over 24 times 24 over 7. Well, they're reciprocal, so you just get 1. So that's pretty much about it. Okay. All right, so that's that one. Okay, the next few problems just get you used to your calculator. Okay, so if you have a calculator, try these out. You don't have your calculator right now, just take notes, but make sure you can do it on your own calculator. Okay, use a calculator to compute cosine, sine, and tangent to 3 decimal places. Okay, so any of these would work. Okay, so how about I do 17, 80.06 degrees. .06 degrees. Okay, so the first thing I'll mention is that we're going to do something called degrees and radians. Right now you want to be in degree mode. So on this calculator, I'm going to check my mode. Okay, there's radians and there's degree. So if your calculator happens to be in this mode, which is radians, we'll get to radians later. You want to switch over to degrees. So now I'm in degree mode, so that's what I want. So I can get back out and quit. If you're on this type of calculator, there's a button here called DRG, which stands for degrees, radians, and gradients. Okay, a gradient is another way to measure angles. Okay, so right now I am in degrees, which is what I want. If I press the button, it switches to RAD, which is radians. If I press it again, it's gradients, which we're not going to use in this class, but there is something called a gradient. If I hit it again, then I'm back to degrees. Okay, so there we go. All right, so they just want sine, cosine, and tangent of these things. Okay, so sine of theta, sine of 80.06. Just punch sine, oops, sorry, 80.06 on your calculator. 0.9849, and they say round to 3 decimal places. So that would be 0.985. Cosine of 80.06, I'll show it to you on this calculator. Again, for those of you with a regular scientific calculator, you have to go backwards. So you folks have to hit 80.06 and then hit the cosine button and double check I'm in degree mode. So 80.06 and then hit cosine. 0.1726 rounded off to 0.173. And then tangent theta. So tangent, I would keep this calculator 80.06 and then hit 10. So this is for the backwards type of calculator. 5.706. Okay, so that's all. So that's how to do the problems from that section. Okay, so 13, 15, 7, they're all just getting comfortable with your calculator. Okay. Now, much harder are 19 through 23, where it asks for secant, cosecant, and cotangent. Now, calculators in general do not have buttons for secant, cosecant, and cotangent. You got sine, cosine, and tangent. And by the way, in case you're wondering, that sine with a -1, okay, that does not mean reciprocal. Those are inverse functions, which we'll get to later. Okay, but that's not the same thing as secant, cosecant, cotangent. And likewise for here. So what do? You just take the reciprocal of these things. Okay, so I'll show you what I mean. All right, so I'll show you how to do one of these. Okay, they're all pretty much equivalent. 19, 21, 23. 21 has a decimal. I'll do 21, and you do 19 and 23. Okay, theta is 17.5 degrees. All right, so they want secant theta, cosecant theta, and cotangent theta. Okay, now, my calculator does not have these buttons. There's a good reason for it, okay? Because we just take reciprocal, just 1 over. Okay, that's a lot easier than having a brand new button. Okay, have another button for secant, another button for cosecant, another button for cotangent. That's 3 more buttons that the manufacturer has to put in. And of course, the more buttons there are, the more they're going to charge you, and the price of the calculator goes up, right? So say, okay, we won't have a separate button for secant, cosecant, cotangent. We just know they're the reciprocals. So 1 over, 1 over, 1 over. Okay, and remember the rule I gave you, well, cotangent is easy. Cotangent is reciprocal of tangent. And what are the rules here? If one function has a co, the reciprocal does not have a co. So secant, no co, reciprocal has a co, cosine. Cosecant, there's a co, reciprocal does not have a co, sine. Okay, so I'm going to go 1 over cosine 17.5. Okay, so 1 divided by cosine 17.5. See what I did there? In some of your calculators, you automatically come up with a left paren. If it automatically gives you a left paren, you should close it with a right paren. Okay, and let me see if I can show that to you. Yeah, some calculators, once you hit cosine, it gives you the left paren. Then you folks close it with the right paren. Okay. 1.0456 means 1.046. Okay, cosecant is 1 over the sine. So 1 over sine of 17.5. 1 divided by sine 17.5. Same thing, my calculator doesn't require the parenthesis, so I won't put it. Oh, I forgot to put the 17.5. My bad, I think got that wrong. But anyway, let me get this. 3.326. I messed up on here. It didn't give me 17.5, it just had 17. So let me do that again, sorry. 1 divided by cosine 17.5 is what I want. 1.049. Okay, so it's a little bit off. 1.049. All right, and how do I do it on this calculator? There's a reciprocal button, 1 over x. On my calculator, it's above the x squared. That's how I get the reciprocal. So I'll take the tangent of my theta and then hit the 1 over x button. Okay, so I want tangent of 17.5. So 17.5 is a little bit tricky on this type of calculator, the backwards calculator. 17.5, and then I'll hit 10. Where's tangent right there? 0.315, blah, blah, blah. And then I want to do 1 over x, the reciprocal button, which is right here, which is second function 1 over x. 3.172 rounded off. 3.172. And there we go. Okay, so that's how to do that kind of problem. All right, now, again, my goal is to show you at least one of each different type. So when you get the homework problems, look at the ones that we did in class. So like 13, 15, 17, they're all related, right? So I did 17, you do 13, 15, 19, 21, and 23 are very similar. I did 21, you do the others, right? That's been my theme the whole semester, show you one of each type. Okay, so 25 to 35 type, how do you do that? You use the given information to determine the values of the remaining 5 trig functions. Assume all the angles are acute. When radicals appear in the denominator, rationalize the denominator. Okay, so how do you do stuff like that? Okay, so sine of theta, cosine beta, and all that stuff. Okay, so let's see, 27 looks a little bit complicated. Okay, so let me do 27. Cosine beta is radical 3 over 5. Cosine of beta. Okay, so make my triangle beta. Okay, cosine ka is what divided by what? Adjacent over hypotenuse, right? So adjacent, radical 3, hypotenuse is 5. And I got to figure out the opposite side, which I'm just going to call x right now. And use my Pythagorean theorem. X squared plus radical 3 squared equals 5 squared, right? So square root of 3 squared is just 3. 5 squared is 25. Subtract 3. X squared equals 22. Square root, x equals radical 22. No need for plus or minus. These are all distances, so they're positive. So the opposite side is now radical 22. Square root of 22 there. So now I can do everything. So sine beta, cosine beta, tangent beta, fraction, fraction, fraction. Now I can do my Sohcahtoa. So sine is opposite over hypotenuse. So radical 22 over 5. Cosine beta adjacent over hypotenuse, radical 3 over 5. Tangent of beta is opposite over adjacent, so radical 22 over radical 3. Okay. It says rationalize the denominator. I'm not going to do that. I don't see any point in doing it. Just leave it as radical 22 over radical 3. And reciprocals. Reciprocal of sine is cosecant. Reciprocal of cosine, there's a co, so secant. and tangent and cotangent. Okay, so just flip it. 5 over radical 22, you may leave that. 5 over radical 3, you may leave it. Radical 3 over radical 22. Okay, if we need to rationalize the denominator, I'll tell you when. Okay, but to me, it's kind of pointless. You end up writing more stuff unnecessarily, in my opinion. Okay, so that's how you do that type of problem. And I'll show you maybe one more with one of the reciprocal functions. So 25 through 35 are all like that. How about I do 35 cotangent alpha? Okay, so cotangent alpha is radical 3 over 3. All right, let's switch to the reciprocal. Flip it. Tangent alpha is 3 over radical 3. Now, here's an instance where it's actually worth it to rationalize the denominator. If you see this number and this number is the same, okay, and I'll show you why. So from algebra to rationalize the denominator, you recall you go like this, multiply the top and bottom by radical 3. Because that enables me to go like this. What is radical 3 times radical 3? 3. Cancel, cancel, cancel. So you have radical 3, which I'm going to choose to write as radical 3 over 1. Okay, so if you're given a whole number, you can always make it over 1 in order to do my Sohcahtoa. It's always a fraction, right? All right, so same game. Here's alpha. Okay, tangent Toa, opposite over adjacent. So opposite, adjacent is 1, and I have to figure out the hypotenuse, which is x. Okay, so 1 squared plus radical 3 squared is equal to x squared. 1 squared is 1. Radical 3 squared is 3 equals x squared. X squared equals 4. So x is equal to 2. Okay, and then you can get the rest of it. Okay. In fact, that happens to be a quote unquote famous angle, but let's just pretend we don't know that yet. All right, so sine alpha, cosine alpha, tangent alpha. Sine is so opposite over hypotenuse, radical 3 over 2. Cosine theta, ka, adjacent over hypotenuse, 1/2. And tangent, we already got that. Radical 3 over 1 or just radical 3. And then the reciprocals. Cosecant alpha, secant alpha, cotangent alpha. And yeah, cotangent, we already had that. That was given, radical 3 over 3. And just flip these. 2 over radical 3. And again, in my opinion, it's not worth cleaning that up. Just leave it. And flip 1/2 and you get 2. Okay, that's how you get that. Okay, problem's finished, but in this case, it's actually one of our quote unquote famous angles. Cosine of what angle is 1/2? 60 degrees, right? Okay, so the angles that you want to be somewhat familiar with are multiples of 30, multiples of 45. So this little mini table, which you can put on your cheat sheet, okay? For 30 degrees, 45 degrees, 60 degrees. Again, if we were meeting face to face, I'd make you memorize it. So there we go. Okay, so the last type of problem, and then I'm done with 6.1, I can get started with 6.2, is 37 to 45. So verify that each equation is correct by evaluating each side. Do not use a calculator. Okay, they're trying to get you set up for future formulas that we're going to see, actually. And they want you to get comfortable with this little table. Notice the angles that they give us in 37 to 45, they're only 30 degrees, 60 degrees, 45 degrees. That's it, right? So they just want you to plug in stuff and show that it works. Okay, so I'll show you how to do a couple of them. Let's see, 39 looks like it's semi-complicated. 43 looks a little bit complicated. Okay, so I'll show you those. Okay. $39. Sine squared of 30 degrees plus sine squared of 45 degrees plus sine squared of 60 degrees equals 3/2. Okay, the first thing you want to notice is the convention, a new convention when you're squaring trig functions or anything else. Okay, so when we write this, we say sine squared of x, it means this. Sine of x times sine of x. We will say sine squared of x. Okay, we don't write it like this. Can you guess why we don't want to write it like this? This means the sine of x squared, and that's not necessarily the same. In fact, in general, it won't be the same. Okay, so this means the sine of x times x. Okay, so get comfortable with this notation. Sine squared of x, they put the 2 over here. Again, if you put the 2 over here, it means sine of x times x. Okay, so if you want the sine of x times sine of x, you write it like this. And this means sine squared of x. Okay, it means the same thing as this. All right, so that means I want the sine of 30 squared. What's the sine of 30? 1/2. 1/2 squared. Sine of 45 degrees. Sine 45 degrees is radical 2/2. Sine squared of 60 degrees. Sine of 60 degrees is radical 3/2. Okay, work that out. 1/2 times 1/2 is 1/4. What's the square root of 2 squared? 2. 2 squared is 4. Square root of 3 squared is 3. 2 squared is still 4. So I have 1/4 plus 2/4 plus 3/4, 6/4, which does reduce to 3/2. So it is verified. Okay, so the idea behind these problems, just work it out and hopefully get the same thing. Okay, 43 looks kind of complicated, but we're going to see that as a formula later. Sine of 30 degrees is the square root of 1 minus cosine 60 degrees divided by 2. Okay, how do you do that? Sine of 30 degrees equals square root of 1 minus cosine 60 degrees divided by 2. Sine of 30 degrees is 1/2. Okay, this one's going to be very clumsy, actually. Cosine of 60 degrees. Cosine of 60 degrees is 1/2 divided by 2. Well, what's 1 minus 1/2? 1/2. Shouldn't put this. 1/2 divided by 2. 1/2 divided by 2 is the same as 1/2 times 1/2, which is 1/4. And the square root of 1/4 is indeed 1/2. Okay, so it does work. Remember, if you divide by 2, you multiply by 1/2. So it's 1/2 times 1/2, which is 1/4. And the square root of 1/4 is 1/2. So that actually works. Okay, and then maybe the last one, 45, it's a little bit clumsy. Tangent of 30 degrees is sine of 60 degrees over 1 plus cosine of 60 degrees. And that'll be it. 45. Show that tangent of 30 is sine of 60 degrees over 1 plus cosine 60 degrees. Okay, so tangent of 30 degrees, tangent 30 degrees, radical 3 over 3. So the left side's done. Sine of 60 degrees, radical 3 over 2. Over 1 plus cosine 60 degrees. Cosine 60 degrees, 1/2. Okay, make this look nicer if I multiply top and bottom by 2. So 2's cancel out, I have radical 3. 2 times 1 is 2. 1/2 times 2 is 1. So radical 3 over 3. So it checks. Okay, so I have everything that I want there. Okay, so that pretty much does it for that one. All right, so I've given you everything I wanted to for 6.1. And I'm ready to start 6.2. See, we have 1 and 9, 10, 13, and 25 odd. Okay, so these are applied problems with trig. Okay, they're word problems for the most part. But essentially, it's still doing a lot of Sohcahtoa. Okay, so let me show you 6.2. Right triangle applications. So they're word problems. You use the words with Sohcahtoa to get the distances that you want, hopefully. Okay, so I'll show you how to do that now. Okay, 6.2 is 1 to 9 odd, 10, 13, and 25. Okay, again, let me show that to you. 1 through 5, 7, there's 8, 9, 10, and 11. Hopefully you can see that. Okay, and how high did we have to go? 25. There's that. That. Okay, some more stuff here. And now we got some interesting polygons here. And we had to go up to what, 25 was it? Where's 25? Yeah, there we go. And 23, okay. So hopefully that shows you everything you need. Okay, what time is it? Okay, so I'll do a few here, then after the break, we'll do more. Okay, is 3 over 2 preferred over 1.5? In general, for these kind of problems, it is, especially if you have to do operations on it, right? If you have 1.5, let's say if you have to do 1.5 times something, right? Well, you got to change it to 3 over 2 anyway, right? So that's why it's usually best to leave it as an improper fraction. Okay, but if you leave the answer as 1.5 and it's supposed to be 3 over here, I won't mark yours wrong. That'll be okay. All right, so let me see if I can show you a couple of these before we break. Okay. So 1, 3, and 5 seem somewhat similar. Okay, they tell you some angle and blah, 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 find some distances. Okay. So how do you do that? Okay, so 6.2, page 438. We roughly draw the picture. Doesn't have to be that accurate. And we go C, A, B. Okay, so how about I'll show you number what? 5. Angle B is 50 degrees. AB is 15 centimeters. Find BC and AC. Okay, makes sense. All right, do you recall this rule for any triangle? All 3 angles have to add up to what? 180, right? So you should have heard that before. So for any triangle, A, B, C, A plus B plus C equals 180 degrees, right? For any triangle, angle A plus angle B plus angle C is 180. Now, if you have a right triangle means this is 90. So these two have to add up to 90. So this one's 50, that automatically makes this one 40. Is that right? Okay, so how about I call this X and Y and use trig to find the rest of the stuff. Okay, you actually don't need the 40-degree angle. You can base everything off the 50 degrees. Okay, and I'll show you how. All right, we're trying to find X. So if I use the 50-degree angle, this is which of the 3 sides? In other words, is it opposite, hypotenuse, or adjacent? So 50 degrees, X is considered the adjacent side. 15, hypotenuse. So adjacent, hypotenuse. Which trig function involves adjacent and hypotenuse? Cosine. So cosine of 50 degrees is adjacent over hypotenuse, X over 15. Okay, multiply both sides by 15. X equals 15 cosine 50 degrees. Squiggly equal. Okay, and let's see, round answers to 1 decimal place. Okay, so 15 cosine of 50. 15 cosine 50. 15 cosine of 50. So 1 decimal point would be 9.6. That's why I put squiggly equal. 9.6. Okay. Oh, and yeah, they want that as the distance from B to C. It's distance BC. How about Y? So I'm doing the angle B, which is 50 degrees. Which side is Y? Opposite. I have the 15. So opposite and hypotenuse. Opposite, hypotenuse. Sine. Sine of 50 degrees is opposite Y over 15. Again, multiply both sides by 15. Y is 15 sine of 50 degrees, squiggly equal. And that's the distance from A to C. Okay, and just to help everybody do the backwards calculator for this one. So you folks would do sine of 50 first. So on this regular scientific calculator, just, whoops, I hit 500. I don't want that. I want 50, right? 50, and then I hit sine. Okay, and then times 15. So times 15 equals 11.49, blah, blah, blah. So rounded off would be 11.5. 7.5. Okay, so that's what we're up against, this kind of problem. All right, so how about I show you number 7? A ladder 18 feet long leans against a building. The ladder forms an angle of 60 degrees with the ground. How high up the side of the building does the ladder reach? And let's see, give 2 forms for your answer, one with radicals and one using calculator. Rounding 2 decimal places, and find a horizontal distance from the foot of the ladder to the base of the building. Okay, so let me show you what they're talking about. Okay, so it says you have an 18-foot ladder that leans against a building. Okay. Here's a ladder. And it says this is 60 degrees. Okay, so one more time. An 18-foot long ladder leans against a building. The ladder forms an angle of 60 degrees with the ground. Okay, so they want this distance, the vertical distance, and a horizontal distance. Okay, so A, how high up the side of the building? 7A, how high up the side of the building? So that's this thing. And part B, find a horizontal distance from the foot of the ladder to the base of the building. That's what I'm going to call Y. Okay. So let's see, 60 degrees, opposite, hypotenuse. Opposite, hypotenuse. Sine. Sine of 60 degrees is opposite over hypotenuse. Okay, multiply both sides by 18. X is 18 sine 60. In this particular case, they don't want you to use a calculator. They want you to use the so-called exact form from our table. And it's hard for me to get that back every time. But it was radical 3 over 2. Sine of 60 degrees, radical 3 over 2. Okay, 18 divided by 2 is 9. So 9 radical 3. And this is going to be so many feet. Okay. 9 times square root of 3. 9 square root of 3. 15.588. Where do they tell me to round to? How many digits do they want? 2 places. So 2 places is 15.59. So that's how high up we would go. And then find this distance. Okay, so this is the adjacent side, right? That's still the hypotenuse. Adjacent hypotenuse, cosine. Cosine of 60 degrees is y over 18, adjacent over hypotenuse. Multiply both sides by 18. Y is 18 cosine of 60 degrees. Okay. From the table, cosine of 60 degrees is a half. And half of 18 is 9. So the answer is 9 feet. Okay, so that's the idea behind these kind of problems. All right, so we'll break shortly, but see problem 9, using a triangle, you can figure out some distances. Number 10, we had to do also. 10's an even one, so I definitely want to do 10. I'll show you how to do 10 after we break. Then after that, what do we have? 13 and 25. Okay, so we have some of those. So we'll see how we do time-wise on that. But I guess it's a good time to break now. Okay, so we'll take our usual break until it looks like 12:10. I think is pretty normal. Okay, yeah. All right, break until 12:10, please. Okay, folks, let's pick up where we were. I'll do some more problems, then I'll give you something to do in class, and then that'll be it. Okay, and remember tomorrow, Thursday, so we'll have another quiz tomorrow. Our game plan is to start some of 6.3, and the quiz will not be on any trig. It'll be on exponential and log equations. The basic idea is to, if you have an equation that has an e, you knock it out with an ln, and if you have an equation that has an ln, you knock it out with an e. Okay, so that's what's going to happen. All right, so getting back to here, problems 9 and 10 are somewhat similar, but number 10, you don't have the answer in the back of the book. It's even, so let me do that. Okay, 10. A building contractor wants to put a fence around the perimeter of a flat lot that is the shape of a right triangle. One angle of the triangle is 41.4 degrees. The length of the hypotenuse is 58.5 meters. Find the length of fencing required. Round the answer to 1 decimal place. Okay, so they give you one angle and the hypotenuse. Okay, so let's draw the picture for number 10. So they go like this. You have an angle of 41.4 degrees. Doesn't matter which one it is. 41.4, and the hypotenuse is 58.5. And you're asking for the perimeter distance all the way around. So I got to figure out x and y, I guess. And once I have x and y, I just add them all up. Okay. And a side note, can you figure out what this one would be? Let's do it. We don't really need it, but let's do it anyway. Remember, all three of these angles have to add up to 180. Now, this is already 90. So these two have to add up to 90, right? So this would be 90 minus 41.4. Punch it in the calculator, 48.6 degrees. In case we need it. We actually don't need it, but in a future problem, we might need it, okay? All right, let's figure out x and y. So 41.4, opposite, hypotenuse, right? 41.4 degrees. Here's the opposite side, hypotenuse. So which trig function has opposite and hypotenuse? Sine, right? So sine 41.4 is opposite over hypotenuse 58.5. And the algebra is usually very similar. Just multiply both sides by 58.5, right? So x is 58.5 sine 41.4 degrees. Approximately. Squiggly equal means approximately. And they want us to round to the nearest tenth. Okay. And again, make sure you're in degree mode, not radian mode. I'll double check again. My calculator is radian and degree. Okay, I want to be in degree mode. Again, on this calculator, the DRG thing, if I turn it back on, just look up there, sorry, it says degree. All right, so what am I doing? 58.5, 58.5 times the sine of 41.4. 58.5 sine of 41. So 38.68 to the nearest tenth is 38.7. So 38.7 meters. That's x. Put that in red here. 38.7 meters. Okay, so you can see by using trig, you can find distances without physically measuring them. Okay, and how about y? So 41.4, this is adjacent, still hypotenuse. So adjacent over hypotenuse, cosine. Cosine 41.4 degrees is y over 58.5. Again, multiply both sides by 58.5. Y is 58.5 cosine 41.4 degrees, squiggly equal. Okay, 58.5 cosine 41.4. 43.9, rounded off. Oops, sorry. 58.5 cosine 41.4, 43.9. All right, so perimeter. Okay, this person wants to put a fence here, here, and here. So I just add them all up now. Okay, so we know that was 38.7. Picture's getting too cluttered up here. This is 43.9 meters. All right, so perimeter is 38.7 plus 43.9 plus 58.5 equals so many meters. Okay, so if they want to fence this lot, how much fencing do we need to buy? Okay, 38.7 plus 43.9 plus 58.5. 141.1. Whoops. 141.1, not 141.4. Sorry. 141.1 meters. All right. So that's how to do that one. All right, let's see. 13 is based on this picture here. So it's a roof of a house. Okay, so that looks like a typical roof. They have an H, X, and X, thetas, which are equal. And let's find out what they need. Okay, so theta is 34 degrees, H is 36.5. Okay, so let me put that down for 13. So H is 36.5. Feet. And this angle is 34 degrees. Determine X and determine the area of the whole thing. Okay, well, we know area is 1/2 base times height. Okay, so let's figure out X. Okay, opposite, hypotenuse. So sine. Sine of 34 degrees is opposite, 36.5 divided by hypotenuse, X. Multiply both sides by X. X sine of 34 degrees equals 36.5. Divide both sides by sine 34. So many feet. Okay, that would be this slanted distance from here to here. Okay, and how do they tell me to round off? 1 decimal place. All right, so 36.5 divided by sine of 34. 36.5 divided by sine 34. 65.3 feet. Now, how do I find the area of that? They call it a gable, 12b, but it's that triangular region. So I know it's 1/2 base times height. I have to figure out the base. Let me call this y, and this will also be y. So I'm going to find y, but the entire base is double that, right? All the way across. Okay, so for y, this is the adjacent side, right? That's still the hypotenuse, but let me just use a given number. So this is opposite adjacent, so tangent. It's usually more accurate to use given information. So tangent 34 degrees is opposite 36.5 divided by the adjacent, which is y. Okay, now if you follow the logic that was over here, essentially these two just switch places. You may do that from now on. Okay, in other words, just swap these two to isolate the y. Y is equal to 365 divided by tangent 34 degrees. Okay, so see that? You can swap these. Maybe I'll do a little timeout here. Okay, if I box out a little timeout, if A equals B over C, you're allowed to swap these and say C equals B over A. You can swap these two. Okay, have you ever seen that before in algebra? It's very apparent if I put real numbers in there. Sorry, I'm digressing. 5 equals 15 over 3. We know that's true, right? What happens if I switch them? 3 equals 15 over 5. And you say, oh yeah, sure, that makes sense, right? So anytime you see something like this, you're allowed to just swap these two. 5 equals 15 over 3, 3 equals 15 over 5. So just swap these. So right here, I'm trying to solve for y, right? Just put the y there and the tangent 34 there. Okay, so what is it? 36.5 divided by tan 34. 36.5 divided by tangent 34. 54.1 feet. I want to see what I got there. 36.5 divided by tangent 34, 54.1. Okay, the base, the whole base is double that. 2 times 54.1, which is 108.2 feet. All right, now it asks for the area of this entire gable, they call it. It's a triangle. So area is 1/2 base times height, right? Area is 1/2 BH. So 1/2, the entire base. Okay, I only found half of it. So just double it. So 1/2 of 108.2 times the height, which is 36.5. And it's going to be so many square feet. Remember, area is square units. Okay, so, well, 54.1. The height was 36.5. $1974.7. Like that. Okay. All right, you have some pretty wild pictures here. So how do we do stuff like that? Let's try 17. Find the area of the shaded region. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 sides, is it? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it's 9 sides. Okay, so I'll do 17. Now, I can't draw it very well. Okay, I'll just draw one of those triangles. Okay, there's going to be 9 of them, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's just one of them. Now, if I go all the way around a circle, that's 360 degrees, right? So how much is one of these? There's 9 sides. divided by 9. So this has to be 40 degrees, right? It's 360 degrees all the way around. I'm dividing it in 9, so this is 40 degrees. So I'll go like that. And they tell me that the radius is 1 unit. This is 1. All right, I think I know what to do. Let me extract out that one picture. 1. Now, we said this was 40. What does that make this angle right here? 20, right? That's 20. X, Y. Okay, one more time. There's 9 of them. I can't draw it very well, but there's 9 of them. Here's one of them. There's another one here and another one here, right? All the way around. They're all equal. 360 divided by 9 is 40. So this is 20, X, Y. Okay, so it's a 20-degree one, opposite hypotenuse. So sine of 20 degrees is Y divided by 1, which is Y. Okay. I'll get to that later, but they want an exact value. So 2 of them, this is 2 sine of 20 degrees. 2 sine of 20 degrees. Cosine of 20 degrees is adjacent over hypotenuse, x over 1. Well, that's just x. So the area of the triangle is 1/2 base times height. The base is 2 sine of 20 degrees times cosine of 20 degrees. Is 1/2 base times height. The base is here to here. I figured this out was sine of 20, but there's 2 of them. So 2 sine 20, and that's the height. Looks like the 1/2 cancels with 2. 2, oops, sorry, sine 20 degrees, cosine 20 degrees. That's the area of one of them. We have 9 of them. So for the total area, I just add them all up. So total area is 9 sine of 20 cosine 20. Okay. 9 sine 20 cosine 20. 2.89. This particular case, 2.89. And they don't give any other units, so we'll just leave it like that, 2.89. Okay, so that's how to do that type of problem. All right, so I did 17. Try that concept for 19 and 21, hopefully. Okay, let's try 23. In triangle OAB, OA equals OB is 6 inches, and they give you some other stuff. Find AB. Okay, so how do you do that? Okay, 23. Angle AOB is 72 degrees. AOB, 72 degrees. OA and OB are equal. They're each 6 inches. Find the distance from A to B. Okay, so I'll cut this in half like this. So if I cut this in half, 72 degrees, each of these is going to be half of 72, which is 36 degrees, right? So I'll call that X. Okay, so let me extract out just this triangle on the right side. This is 6x 36 degrees. 36 degrees, right? All right, opposite side, hypotenuse. Which trig function opposite and hypotenuse? Sine. Sine of 36 degrees is opposite over hypotenuse. Multiply both sides by 6. X is 6 sine 36 degrees, squiggly equal. Okay. For those of you that have the backwards type of calculator, you got to go 36 sine. So 36 sine, and then times 6. Times 6. 3.52. How do they want me to round off? 1 decimal place. 3.5. But they want AB. How far is it from A to B? I just doubled this. So AB is 2 times 3.5, which is 7. So the answer is 7. And the units are inches. Okay. So that's that. Okay, 25 is the last one. So I'll do 25 and then I'll quit and I'll give you something to do and then that'll be it for today, okay? 25, I have to kind of reproduce this picture here. Suppose that AD equals 1. Find the length of each of the other line segments in the figure. When radicals appear as an answer, leave the answer in that form rather than using calculator. Okay, so let me try to draw something similar to that picture. Okay. Okay, it's probably better if I don't use my ruler, just freehand it, since it's not going to be that accurate anyway. Okay, I'm trying to draw the picture that they give us here. A, B, C, D, E. 60 degrees, 45 degrees, 30 degrees. AD is 1. Okay, so how do I do that? So find all the other distances. Call this X. Opposite, adjacent, tangent, right? Tangent 30 degrees is X over 1. Well, that's just X. Okay. They want it in radical form. So tangent of 30 from the table, tangent of 30 is radical 3 over 3. So this is radical 3 over 3. How about I'll call this Y? Well, I can now use my Pythagorean theorem, looks like, right? That squared plus that squared is Y squared. 1 squared plus radical 3 over 3 squared equals Y squared. 1 squared is 1. Square root of 3 squared is 3. 3 over 9 equals y squared. Y squared equals 12 over 9. So y is square root of 12 over square root of 9, which is 3. 12 is 4 times 3 divided by 3. So 2 radical 3 over 3. So y is 2 radical 3 over 3. Okay, that's the hypotenuse of this triangle now. Okay, now we know both of these are going to be the same. Okay, that's the way a 45, 45, 90 triangle works. So running out of letters here, how about I'll call this Z? And this is also Z. It's an isosceles triangle. If this is 45, this is also 45. This is a right angle. That's a right angle. So both of these are going to be the same. They're both Z. That's the hypotenuse. Well, how about I'll go Z squared plus Z squared equals 2 radical 3 over 3 squared. Okay. A squared plus B squared equals C squared. That's the hypotenuse. Z squared plus Z squared is 2Z squared. I square these. 2 squared is 4. Radical 3 squared is 3. 3 squared is 9. Cancel, cancel. It's 4/3. Take half of each side. So divide by 2. Divide by 2 means multiply by a half. Z squared is 2/3. Z is the square root of 2/3. And yeah, since I have to keep going, I'm going to rationalize the denominator. So radical 3 over radical 3, radical 6 over 3. So each of these is radical 6 over 3. That's radical 6 over 3. This is radical 6 over 3. So all I have left are this one and this one. How about I'll call that A, I'll call that B. Okay, and maybe I'll abandon the problem and let you figure it out from there, but it can be worked out. Let's see, how much I want to show you. This is 30 degrees, right? Okay, how about I'll aim for the hypotenuse? 60 degrees, opposite hypotenuse. So cosine, sorry, sine. Sine of 60 degrees is opposite radical 6 over 3 divided by what I'm calling B. Switch these two. B is equal to radical 6 over 3 divided by sine of 60 degrees. Sine of 60 degrees is radical 3 over 2. This looks kind of clumsy. If I divide by a fraction, I multiply by the reciprocal, right? So I'll go radical 6 over 3 times 2 over radical 3. So that's going to be 6 divided by 3 is 2. 2 radical 2 over 3. Okay, so I got everything here except for A. I'll leave it to you to figure out A. There's several ways you can approach that. Now that you have B and Z, you can do the Pythagorean theorem. Or you can use trig and use the 30-degree angle or the 60-degree angle to figure out the A. Either way is fine. I'll let you do either way that you wish. Okay. Other than that, I'm done with the section, folks. About 12:40ish. Okay, any questions? You can put it in the chat or unmute yourselves. Otherwise, I'll give you a problem to do and then we'll quit. Okay, I don't hear anything. All right, so if you have your cell phone, you can take a picture or it's in the book. What you do is 6.2, number 2. 6.2, number 2, it's on page 438. So if you have the book, just go to 6.2, number 2. If not, take a picture on your cell phone or take a screenshot. Just answer number 2 for me. I'll hold it for maybe another half a minute. So angle A is 60 degrees, AB is 12. Find AC and BC for me. Put the answer in the chat, and if you're done, you can leave. Okay. If you want to write an answer as a square root, use SQRT for squirt, square root. Okay, so again, number 2, angle A is 60 degrees, AB is 12 centimeters. Find AC and BC. For square root, you can put SQRT. Okay, I'll assume that you have it right now, so I'll make this disappear. So work on that for a while, and I'll